Good afternoon, this is Schweitzer, and this is one of our first practice videos on work. Work is introduced in class, or maybe you watched a video on it, but here's a practice question that you should or would want to be able to answer relative to work and a few other problems here. So this has got a couple parts to it. We got a 300-pound piano is lifted at the top of a building 90 meters high in 80 seconds. Okay, so there's three problems here. I'll tell you when I think you should pause it and try it. But what is the amount of work done? What is the power output of the lifter? What is the piano speed if it's dropped from the roof when it hits the ground? All right, so I would say go ahead, pause this video and give it a try, and then I will work it out, and you can, after giving it a try, see how you do. Okay, so for letter A, it says, what is the amount of work done? Keep in mind, work is equal to force times distance. Work is, can't talking right. Okay, so work is equal to force times distance. Alright, so what does that mean? It means that if I apply a force over the course of a distance, I have accomplished a certain amount of work. Work is a form of energy. So we can hit this thing in two different ways. Of course, joules is energy. You can be given the force, you could be given the distance, and you simply multiply them together and you get your energy that you've accomplished or expended. Or you could possibly find the energy an alternate way. And in this case, what do they give us? They say, well, this thing has a mass of this amount. It's lifted to the top of a 90-meter building, okay, in a certain amount of time. We have the distance, but we don't have the force applied. Of course, we're fighting the force of gravity, so the force is that of gravity. So we could solve it this way right off the bat here. Force is equal to mass times acceleration of gravity. So in this case, the mass is 340 kilograms times the acceleration of gravity, which is 9.8, equals 340 times 9.8 equals 3,332 newtons of force. And so we take, so now the work, which equals force times distance, and this will give you 3,332 newtons times a distance of 90 meters equals 299,880 joules of energy, or it could be 299.8 kilojoules if they asked for it in kilojoules. A lot of times the joules is a small amount of energy, so kilojoules is sometimes your mode of answer. Either way, how do I solve this problem with just straight energy? Well, we know that energy comes in a few forms, and one form is potential energy. Potential energy is mass times height times gravity. And you'll notice that at this point, it ends up being the same calculation. The mass is 340 kilograms. Height is 90 meters. And the gravity is 9.8 meters per second. And you should get the same answer because it's the same calculation. But thought about in a different way, energy, potential energy is in joules. So if I know the amount of energy that I have, well, that is equivalent to the amount of work. B, what's the power of the output lifter? Okay, so B is simply saying power. Power, you should be aware of, is simply energy per time. And this is going to be 299,880 joules per time. So a watt, just so you know, is a joule per second. So I want to be in joules and I want to be in seconds. Seconds is 80. That's moving up. That's a big lift in kind of a relatively short amount of time, in my opinion. But let's do our calculation. Divided by 80 seconds means this guy's putting out 3,748 watts. And don't get this W confused with work. Two different things. Alright, now C is a review question. So it's not a review, it's a review from our maybe a previous chapter, but we'll solve it in a few different, well, let's use energy to solve this problem. Of course, you know that energy comes in a few forms. So energy before will equal your energy after. Another way of saying that is energy in equals energy out, but kind of like before and after, because it's energy generally is generally not lost. I mean, you can change the usable amount of energy, but at some sense, energy is conserved for our purposes. Alright, so we know this thing is going to acquire 2,998.80 joules of energy. Before, we have potential energy and we have kinetic energy. We have equaling afterwards, we have potential energy and kinetic energy. Just so happens that before there's zero kinetic energy and we have 2,998.80 potential energy, and afterwards all energy is converted over to kinetic energy, which is zero potential and all kinetic, 2,998.80. Well, what's that mean in kinetic energy? Well, it's kinetic energy is equal to 1/2 mass velocity squared. So 2,990 equals 1/2 mass, which is 340 kilograms, times the velocity squared. Don't need a parentheses there, but I'll just take them out. Velocity squared, and you just plug away, solve for V. Don't forget to square root your answer. Alright, ends our first problem. Thank you.